My name is Dr. James Evans. I'm Assistant Director of the Whitehead MIT Bio-Imaging Center. The center is involved in technology development for system-scale imaging research. At the Imaging Center we collect a lot of different types of images. It can be as simple as a 2D snapshot of a cell, going all the way up to a 3D image resolved over time. We also collect massive data at high resolution. Images contain a lot of information on sort of spatial distribution of proteins and how cells function, and a lot of that is lost in biochemical or genetic analyses. Imaging has the potential to give us a lot better resolution in not only basic research but also in drug discovery applications. Part of the potential impact of the Imaging Center is in getting more information, better quality information from experiments that use cells or tissue, and using imaging to get that information out. A lot of the problems are that throughput of imaging experiments is usually much lower than certain screening methods that are used in industry. And part of the reason for that is extraction of the information and handling these large amounts of data is quite laborious. Part of the problem is that a lot of other technologies, genomics and proteomics, tend to use population averages for their measurements. So you really typically don't get an individual cell measurement, whereas imaging gives you measurements on morphology or signaling state on a per-cell basis. A typical screen from a high-content imaging system could involve scanning 96 well plates or 384 well plates for maybe 6 weeks or a few months, generating maybe 6 terabytes of images. Data extracted from those images could be about a few hundred gigabytes of spreadsheet data. So boiling that down to find out sort of what the real trends are is quite challenging. Working with STAR-P, it now enables us to try out different ways of visualizing data or mining through data. A lot of what we do is trying things that ultimately don't work. So it's nice to be able to have a method that enables us to try things, see if they work, maybe tweak them, optimize them. STAR-P, means that we can actually, instead of waiting, hours for a result, we can get a result back in a few minutes and maybe modify it or start from scratch. Some of the benefits of STAR-P for our research has been that we can stay with the application MATLAB that we are sort of used to, and we have existing code that we don't have to start afresh in a new environment. We don't have to have specialized custom hardware to run the software. It's pretty seamless, easy to use. STAR-P has been helping me with k-means clustering. It's really tried and tested approach for mining lots of sort of massive data and trying to find groups within the data that behave similarly. As an example, STAR-P allowed me to bring my k-means process down from taking several hours to taking just 10 minutes or so. Prior to having STAR-P, I tried several other packages for mining massive amounts of data and been frustrated by either the inability to get the data into the visualization package and back out, or the inability of the package to scale above 2 or 4 gigabyte limit imposed by a 32-bit operating system. So now using MATLAB on a 64-bit environment, accelerated with STAR-P, I'm able to handle large data quickly. So it's definitely been, I've got through a roadblock. There are things that we can do now that you couldn't dream of doing. To be able to handle spreadsheets that are 50 gigabytes, 14 million lines, 200 rows, it's just unthinkable. I'd recommend StarP if the company was sort of already had a good user base of MATLAB sort of experts, and they wanted to just take that expertise and accelerate the rate of productivity or discovery by that group. Instead of just sitting around for things to run that take usually a day or two, you get your answers back within 5 or 10 minutes, and it's a lot more exciting. You get those sort of discovery moments that all scientists love.